Today I am going to discuss about thermodynamics property. So there are certain characteristics by which physical condition of a system may be described. Means when you describe a system, there is some certain characteristics are there. That is pressure, volume, temperature, or entropy, enthalpy. Such characteristics are known as properties of a system. When all properties of have a definite value, then the system says to be exist or exist in a definite state. Property are the coordinate to describe the state of a system. Basically, two types of properties are there. First one is intensive property, extensive property. What is intensive property? When the properties is independent of one mass or size, that is pressure, temperature, density, viscosity, etc. What is extensive property? Extensive property means which the property which depends upon mass or size, that is volume, enthalpy, entropy. Next one is what is specific property? It is defined as the ratio of extensive property to mass or extensive property per unit mass. Specific property equal to extensive property per mass. Example, specific volume equal to volume per mass. Similarly, specific enthalpy equal to enthalpy per mass. Specific entropy equal to entropy per mass. So you have to remember one note. The ratio of two extensive property is an intensive property. The specific extensive property are also known as intensive property. So how to check a property? If an expression is given by dp equal to mdx plus ndy, then it is said to be a property of the system if its differential is exact. Means del m by del y of x equal to del n by del x of y. So now I am going to solve a problem. If the differential parameter of wf is given by dwf equal to pdv plus vdp, check whether it is a property or not. Here dwf equal to pdv plus vdp. This above expression is said to be property of a system if its differential is exact. Means del m by del y of x equal to del n by del x of y. So now here see del p by dp of b equal to 1. Similarly del v by dv of p equal to 1. So it satisfies the equation del m by del y of x equal to del n by del x of y. Hence it is a property of system. Now I am going to discuss about state and its representation on PV diagram. What is state? State, it is the condition of a system defined as the value of property of a system. Means see here in a PV diagram, here some points are there. One point P1 V1, here another point P2 V2. Okay, so the condition of a system defined as the value of property. Here one point means here the point have some value, that is here the pressure is P1 and volume is V1. So that is known as your state. Okay, here one state, first state means initial state, your pressure is P1 and volume is V1, and second state pressure is P2, volume is V2. So change of state. What is change of state? Any operation in which one or more properties of the system change, then it is known as change of state. Means see here your initial state is P1 V1, means at that point your pressure is P1 and volume is V1. After some time when it's changed its state, the final state, your pressure is P2 and volume is V2. So it is known as your change of state. Then what is path? The suction of state passed through during the change of state. Means this, see, when initial state is P1 V1 and final state is P2 V2, the suction of state means this suction. Okay, the suction of the state passed through during the change of state. Means initial state to final state, when it goes to initial state to final state, the succession of state passed through during the change of state, means this is known as your path. What is process? When the path is completely specified, then the change of state is known as process. Means this process means initial state is 1 and final state is 2. So when the path is completely specified, then it is known as your process. What is cycle? After undergoing a series of state change, if the initial state is identical or same with the final state, then it is known as a cycle. Means your initial state is 1 and final state is also 1. Means both the states are identical, then it is known as your cycle. So minimum 2 processes are required to complete a cycle. Remember this, minimum 2 processes. Process 1 to 2, then 2 to 1. So to complete a cycle, minimum 2 processes are required. So what is cycle? After undergoing a series of state change, if the initial state is identical or same with the final state, is known as cycle or thermodynamic cycle or cyclic process. So in the above diagram, see in the PV diagram, your 1 to 2 is known as your process. Again 2 to 1 is a process. So 1 to 1 is known as cycle. So now I am going to solve a problem. Find out the properties, state, path, process and cycle from the figure given below. Here it is a figure is given to you, PV diagram 1 to 2, A, B, C. So here now I am going to draw the diagram, PV diagram. So it's a P1, P2, B1, B2. So here properties is only pressure and volume is given to you. So that is known as your properties. What is path? Path is 1 to 2 means A, B, C. Okay. That is your path. What is state? State is initial state is 1, final state is 2. Okay. Then what is process? Process is 1A2, 2B1, 2C1. That is known as your what? Process. Okay. 1A2, 2B1, 2C1 is known as your what? Process. What is cycle? Cycle is 1A2B1, one cycle. 1A2C1 is second cycle. Okay. Now come to discussion about point function. So what is point function? If you located a point on a graph by any two properties of a system, then the properties are called point functions. Suppose I am drawing a PV diagram. I am located a point. In that point, your P1 and B1 is given to you. So if you located any point on a graph and if you give some graph by two properties of a system, then it is called a point function. So point function is pressure, volume, temperature. Its differential is exact. Means integration of dp 1 to 2 is p2 minus p1. Integration of dv 1 to 2 is equal to v2 minus v1. Integration of similarly dt equal to t2 minus t1. Similarly, what is path function? There are certain quantity which cannot be located on a graph by a single point, but they can be known by the area under the process. Such quantity are known as the path function. Means it is not located by a point. It is the area under the graph. So area equal to P into B2 minus B1. It is PdV. So here it is PdV. So example is work, heat. So its differential is not exact. But remember, in point function the differential is exact. But in path function its differential is not exact. Means integration of dw not equal to w2 minus w1. But you can write it is w1 to 1 to 2 or w1 to, means it is a process. Similarly, integration of dq 1 to 2 is not equal to q2 minus q1, but integration of dq 1 to 2 equal to Q12 or Q122 or Q12. Got it? Okay, thank you.